welcome to Motorhead Garage. You know, Sam and I made the trip out here to California to B&M Automotive Group. And what we're doing out here is learning a few things, and one of them is how they create a new product and then bring it out to the market. What we're talking about here is with this Mustang. One of the things that we're learning about is they wanted to make a new differential cover for it. Well, how do they come up with an idea for that, and how do they make it? We're going to show you all about that. There's a reason why they want to do this. First of all, the old diff cover on these things is stamped steel, comes from the factory, does a great job what it does. But if you're talking about performance, you want to have a little bit more strength back there. So they can add strength to it. They want to also cool that diff a little bit so they can design fins into it. And besides that, they want it to look good as well. So we're going to find out how they do that. But Sam's got his hands full over here.
All right, what we've got here is pretty common. You see these cars everywhere. Early Camaro. It's got a small block Chevy in it, set of headers. And this has got a turbo 400 in it. And you can tell that by the big oil pan. And of course, if you use it right, it's got an electric kickdown. There's no TV or kickdown cable on these transmissions. And it's got a performance oil pan. It's got a few leaks, but it's got this chrome steel oil pan. We're going to change that. We're going to put a nice deep sump pan from B&M. You can see it's deep. Cast aluminum, it's a rugged pan, it looks good, it fits good, not gonna rust, holds more fluid. The more fluid you have, the more heat you dissipate, and that's the #1 killer of these automatic transmissions is heat. Plenty of fluid, clean filter, and the right kind of fluid, and you can really make a transmission last a long time. First step is, we're lucky, this has got a drain plug in it, it's an aftermarket pan, and it's leaking all over the place. We're gonna take care of all that at one shot, make this guy's Camaro a lot better. So I'll drain it out, take all the pan gaskets down, and clean it up, get it ready for a filter and a pan kit.
Well, now we're here in engineering with Kenji Takahashi, who is the engineer for this. Now, Kenji, when we start out to develop a new product for a car, in this case, we're going to be doing the diff cover for a Mustang. What is your first step? Obviously, you got to get some Mustangs in, right?
Sure. We get a stock Mustang in. We'll take off the rear differential cover, and we'll bring it over to our CMM and measure it up.
Now, CMM is what?
It's a coordinate measuring machine.
Okay, so that's a computerized measuring machine where you could really get some exact measurements from the old piece, right?
Sure, yeah.
All right, now once you have all those measurements, what's your next step?
We'll actually print out the format of the cover, and we'll put the cover down, and we'll make sure that we're within the specifications of the original cover to make sure all our measurements are right.
So you see how important it is to get that accurate before you start. And speaking of accurate, I wonder how accurate Sam is out there.
All right, we're gonna take the bolts out of the pan. Remember, there's some longer ones that hold the bracket up. So you're gonna get new bolts with the oil pan, but you wanna be real specific where these that hold the bracket up go because, again, they're long. I'm gonna take all of these bolts out. It's okay to use an air ratchet or whatever. Take them out. When you put them back in, there's this very specific torque. 13 to 15 foot-pounds is not a lot, but that's what it calls for so you don't destroy the gasket. So what I like to do is put just a little bit of blue thread locker on the bolts. That's not a lot of torque, and that way you know they're not going to vibrate loose. I get the rest of these bolts out and pull the shift linkage down, and pan will be off. And now here's a little tip. I only got 2 bolts left in this pan. If you have a drain plug like this, you're lucky. You get the fluid out. Otherwise, the pan's going to be full of fluid, so leave a bolt in the front of the pan tight. When you take these back bolts down, it'll come down just a little bit. Then you can loosen this one, and as you do, the pan's going to tilt gradually. Fluid will come out into your drain pan. That way you don't make a mess. When I get this pan off, I'll be able to pull off the old transmission intake filter, and we'll clean the gasket surface and get ready to install our new deal. Here's a tip. Like anything else you take apart, use it as a diagnostic tool. Look in the pan. Now, obviously, this guy's been hammering this Camaro pretty hard. Fluid's burnt, not pink anymore. It's not a good sign. There's a little bit of clutch material in here, but it's not bad. It's just overdue for a service. And the little silvery stuff, that's flash that comes off the Torrington bearings and the thrust washers and stuff. But, you know, the best thing you can do for a transmission is change the fluid on a regular basis and use a high-quality fluid. I'm going to show you something nice when we go back with the oil pan. So we're going to clean up the pan gasket surface and take this filter off. And again, the pan we're putting on is going to be deeper. So what we'll do is we'll show you how to handle that when you put the filter in, because the filter is going to have to move down in order to be in the right position to pick up the fluid. So while I'm taking this off, cleaning this all up, we're going to take a break. Stick around. We've got a lot more coming here at Motorhead Garage.
Yeah, you still have to do it on paper, don't you?
Yep.
Hey, welcome back to Motorhead Garage. Well, we're here in the engineering trying to develop a new diff cover for a Mustang. Now, we've got it down here on paper, But it's really important to have all the exact measurements before you start, don't you?
Yes, we do. Once we get all the exact measurements down and we're happy with the design, what we'll do is go ahead and put it into the computer. We'll draw it up here, and once we get the casting, then we'll work on the machining from there.
Now, if you're going to replace this, you know, you're going to make a new housing or a new cover on this thing, rather than just making a new cover, you already got one that's there. What do you want to do different to this now? You can design all kind of things in this, so what is your priorities on that?
Well, we can choose materials. Like for instance on this one, we're choosing a cast aluminum, which will actually allow the heat to transfer through the material much quicker. You'll be able to cool off your differential a lot faster. We'll also put in cooling fins, strengthen the casting itself so that you actually have a structural member of the differential now.
So with the computer now, once you have all that information logged in, then you can really play with that design, do a lot of different things with it.
Sure, we can play with it. We can make sure all the machining works out right. We can check loads, check strength. We can also even check cooling efficiency by running flow across the differential as well and actually see the cooling capacity.
Now, how do you determine what type of material, like aluminum? I mean, there's all kinds of different grades. This is a casting, I assume, that you're doing, right?
Well, we'll do a cost analysis. We'll look at cost, so we'll keep the cost down to the customer, but we'll also look for what is, the best quality aluminum as far as heat transfer. We'll look at strength, and we'll compare the two and then be able to choose a material. This computer system will actually allow us to choose several different casting materials and actually analyze them.
That's great. So you try to get the best cost and the best product for the money there. Let's see what Sam's up to.
All right, let me give you a couple of tips. You've got to read instructions or you'll get in trouble. All right, now, and this is going to drip for days. You're going to get it all over you. This little tube that connects the filter to the intake port. Oops, I just dropped an O-ring. There's two O-rings. They'll always have one stick up there just like that. Now, this tube has two O-rings on it. You're not going to put the old ones back. You're going to put new ones. But remember, we're putting a deeper pan, so we need to bring the filter down lower. So this needs to be extended. You get a nice little piece in the kit. It's aluminum. Comes from B&M. You put an O-ring in there, which they supply. This slides on here like that. You want to put a little bit of transmission fluid on these. Put two O-rings on this shoulder, and there are two back to back. Then this goes up in the case. Push that up until it seals. Now we're ready for our filter. Filter's going to lay in here like that, and you can see it's going to be down a little bit lower because the pan's deeper. We want this to always pick up the fluid. And you see the intake on these is always on the top. You have it on the bottom, and you get a lot of debris in the pan, which you shouldn't have, but it'll plug up. This way it doesn't starve it. So while I go ahead and put this up, get ready to put our pan on, let's go back inside where it's nice and clean and dry, and Davey's checking out that prototype.
Kids, you got all kinds of numbers on there. That is impressive what you do with that print. Now, once you have it pretty well figured out, then you can come up with this. Now, how do you make one of these?
Well, basically, once we're happy with the design, I can go up here and just hit print, and in a couple hours, we have a hard part ready to go and fit up on the car.
Now, how is this done?
This is actually what they call a 3D printer, and it'll print layer upon layer and actually build that part. Basically much like you're printing a sheet of paper and you're just stacking them on top of each other.
It's an amazing thing to see, folks. If you ever get a chance to see how this is done, if you go to a trade show or something, they'll have them in operation a lot of time. But right from a computer, you can go right into actually making in this particular case, a plastic part. So then you can see exactly what it's going to look like, and you can fit it up. This is pretty neat. And if it doesn't fit quite right, then you come back, make your changes on your computer, print out another one, right?
That's right.
And this does what? This can really save you a lot of time, a lot of money.
That's the thing. This is really a time saver. It's a little bit expensive, but actually you gain it in the time that you're able to develop and actually change design and develop new parts and work through several designs in just a few days or a couple hours even.
And in the old days, what they would do is you'd have a print, and then you send it to a pattern maker, and he'd make it out of wood or something, and it'd take days to make that, and if it wasn't right, it'd have to do it again. So this really saves a lot of time. We're going to take a short break. When we come back, we're going to take this out here and put it on our Mustang and just see how good it does fit. So stay with us.